Today I want to take a little closer look at the distributive property. To multiply a sum, or to multiply a difference, you're going to multiply each number within that parentheses by the number outside of the parentheses. Let's take a look at a sum. Well, I have 3 times 2, and I have 3 times 6. The key to this is to remember to share it with both terms within that parentheses. 3 times 2 is 6. 3 times 6 is 18 for an end result of 24. We can do that with a difference, 7 minus 4. Again, let's multiply the 6 times 7 and the 6 times 4. Simplify, and we have 18. Sometimes the expression within the parentheses has a variable term. We'll still do the same process, 5 times 3x and 5 times 7. Now when I look at this, 15x plus 35, it can't be simplified any further like the previous problems because they're not like terms. Let's see that again. This time I'm multiplying by a negative, so I need to watch my signs. I get a negative 8x. A negative times a negative will give me a positive 12. Again, cannot simplify because an x term and a constant are not like terms. This last one's slightly different because it says the opposite of what's in that parentheses. So the opposite of is as if I'm saying let's multiply by negative 1. Multiplying by negative 1 is using my property of opposites, which means the signs inside the parentheses will change. And there's your end result. Now, using the distributive property, we can use that for some mental math. If I'm giving you a problem like 20 times 102, I could think of 102 as 2 parts, 100 plus 2. And now I can go ahead and distribute, which means I can use my mental math to get 20 times 100. And I can multiply 20 times 2. And my end result, 2040. Word problems are another way that we can apply the distributive property. Imagine that your club sold calendars for $7 a piece, and you sold a total of 204 calendars. I want to know how much money, so I'm circling the key things. I have $7, we sold 204, and I don't know how much money we raised. So let's take a look. If I sold 7 times 204, well, that's not a difficult problem to multiply. However, I can break 200 down to 200 plus 4. So 7 times the 200 plus 4. That now says I can distribute and multiply the 7 times 200, multiply the 7 times 4, and then I get a total of $1,428. So you see so you can see here that the distributive property comes in handy for a lot of different reasons. Let's now look at a few practice problems. Well, before we get there, actually, let's look at another application of distributive property. Suppose you had to multiply 8 times 15, the product of 8 times 15 minus the product of 8 times 5. We see that they have a common factor of 8, so we can sort of reverse the distribution, and we'll take that 8, and we'll have in parentheses 15 minus 5. We now can go ahead and use sort of our our order of operations and solve that mentally. Let's see that a second time. I have 7 times 21 plus the product of 7 times 9. So I can now look at this as 7 times 21 plus 9. Now the reason why I'm doing this is because I see a connection with these numbers that easily allows me to do the calculations. One last one. If I'm asked to find the value of this expression and I notice they have a common factor, I can then place the other factors in the parentheses and simplify and get my answer. So here are some various ways to do mental math that maybe you never thought of before. So here are a few practice problems, and again, the distribution term can be on the left or the right, but you're still going to multiply both terms. The key is to remember both terms. I put a couple of problems with just numbers and a couple with variables for you to try. We'll go over those answers in class. If you wanted to see one with variables, allow me to do one before you finish the rest. Again, that's 7 times 2x is 14x, and 7 times 3y is 21y. Again, in the next slide, we'll be talking about those like terms again. These are not like terms, so they cannot be simplified. When we ended last class, we had all of these vocab terms on our slide that you copied into your notes. And I want to spend a little more time talking about them. So I'm going to look at this expression, 7x plus 4 minus 3y plus 2x. The first question I'm going to address is how many terms are in this expression? Well, I have 1, 2, 3, and 4. There are 4 terms. Let's list those 4 terms. 7x is one term. I have a positive 4. I have a negative 3y, take the sign in front, and a 2x. Those are the 4 terms that are in this expression. Now the next question is, are there any constants? Well, that definition of constant says it's a number without a variable. The answer to that is yes. What is the constant? It's 4. Are there any like terms? Same variable raised to the same power? That would be another yes. And those 2 terms are 7x and 2x. So they want me to combine them. So 7x plus 2x would give me a 9x. Because they're like terms, I can add them. So let's simplify that original expression. By combining the like terms, I have 9x plus 4 minus 3y. I have now created a 3-term expression. Those 3 terms are 9x and 4 and negative 3y. I believe there's one last question. That last question says, let's name the coefficients. Coefficients are numbers in front of variables. So I have 9 and I have a negative 3. Coefficient is just a number, not a variable. A number in front of the variable. We'll be doing a number of these problems in class. I just wanted to give you a sample. See you in class.